So our question is asking how much heat energy it takes to get from 1334 degrees Celsius to 1691 degrees Celsius for 45.12 grams of nickel in solid form. So to do that, we have to look at our melting point, which is 1453 degrees Celsius, which is right in between that temperature change. That means that there's a phase shift right in between our temperature change that we have to take into account when we're calculating our heat energy. Meaning that we have to change our temperature change, this whole thing, into 3 different parts. So our part 1 is going to be referred to as Q1, Q meaning heat energy. And that is going to include a 119 degrees Celsius temperature change, which is just 1453 minus 1334. And that's going to be a temperature change in the solid form because our nickel begins in solid. So to do that, we're going to use that Q equals MCAT method. We'll get to that a little bit later. And we're going to be using a specific heat solid of 0.1061 calories per grams times degrees Celsius, because our nickel is in solid form here. Then we're going to use our Q2 to represent our second part of this question, which is a phase change. So because this is our melting point, that means that here we're going to use our heat of fusion, which is the heat energy it takes to change the state from solid to liquid, also known as melting. So there's not going to be a degree shift change here. This is only going to be changing the phase from solid to liquid. Then we're going to do Q3, which is a 238 degrees Celsius increase in temperature in a liquid. And that's just 1691 minus 1453. So for that one, we're going to use our specific heat liquid. So starting with our Q1, we're going to be using Q equals MCAT, or Q equals M for mass, C for specific heat, in this case solid, times our delta T, which is our change in temp. So for Q1, it's going to be equal to 45.12 grams of nickel, which is our mass, times 0.1061 calories per grams degrees Celsius, which is that specific heat solid, and then 119 degrees Celsius, which is that change of temp when we're in solid form. So always make sure that you're crossing out your units to make sure that you end with the right units. So that grams cancels out with that grams here because that's in the denominator. And then degrees Celsius is also in the denominator. So we're going to cancel that out here. And we're left with calories as our units. If you multiply that together, you'll get 569.7 calories. I did that in 4 sig figs because we have that given mass that also has 4 sig figs. For Q2, that's going to be our latent heat change, meaning that there's no change in temperature and it's just a phase change from solid to liquid. So because there's no change in temperature, we only have to care about our mass and then this heat of fusion, which we're going to use as our conversion factor. So we'll have 45.12 grams of nickel times that conversion factor of heat of fusion of 71.71 calories per grams. So if we multiply those together, crossing out our units, we're left with units of calories, and that'll end up being 3235.6 calories. And that's our Q2. Now if we go to Q3, this is the degree change in liquid state. So that's another one, right? That's just from here to here. And we're going to be using our specific heat liquid now. So that's 0.1750. So same as the first shift, that first Q1, except this time we're going to use our C liquid. So 45.12 grams, which is our mass, times 0.1750 calories per grams degrees Celsius. Make sure you're crossing out those units again, times 238 degrees Celsius. So multiply that together and you'll end up getting 1879.3 calories. And that is the heat energy it takes to get from 1453 degrees Celsius to 1691 degrees Celsius in liquid form. Next is we have to find out what the Q total is. So we're going to take Q1 plus Q2 plus Q3. If we add those together, we'll end up getting 5,685 calories. Now I rounded this to 5,685 because there's 4 sig figs in that mass that we want to take into account. Last step is it wants the result in kilocalories rather than calories, which is where we're at now. So we're going to take our 5,685 calories and we're going to multiply that by a conversion factor of 1 kilocal is equal to 1,000 calories. So our calorie unit is going to cancel out. We're going to be left with kilocals, and we're going to end with this 5.685 kilocals is going to be our heat energy that it takes to get from 1334 to 1691 degrees Celsius, which includes that latent heat phase change from solid to liquid.